Okay, so the title, if you're kind of like taking notes or what, however you're organizing your what we do, but the title would be considered functions and transformations. Okay, so the first thing that we're going to look at are just the 6 basic functions, and you'll see these functions throughout this course. So the first two are the quadratic function and the cubic function. So the parent function of a quadratic is y equals x squared. And then, of course, the graph is the parabola. And then for a cubic function, y equals x cubed to the power x to the power of 3. So a quadratic function has one turning point, which is that vertex. And then the cubic function has two turning points. And we'll talk about kind of the features of those in a little bit. So you have your, probably want to write down the parent function and then just a sketch of the graph.
Okay.
Okay? Tell me when you're good and we'll go to the next slide.
Okay, I'm ready.
Good?
Yeah.
Okay, next two are the absolute value function, which is y equals the absolute value of x. Those are what those two kind of bars are. And that produces a V-shaped graph. And then on the right, you have your square root function, y equals the square root of x. And the square root function is a specific function that has a restricted domain. So if you can't have negatives under the radical. And so when we look at domain and range, we remember that square roots have like a starting point. And this particular one starts at the vertex, excuse me, at the origin. Sorry, 0, 0.
Okay.
Good? You good there?
Yeah.
Okay. Okay, I think these are our last two. The exponential function, which is the function y equals, here it's y equals a to the power of x, but it's really just kind of depends on the text that you look at. A lot of times it's y equals a times b to the power of x, where b is your base, what's being raised, and b determines whether the exponential function is going to be growth or decay. And when we get into that unit, you'll see kind of what that looks like. But exponential functions have asymptotes. Basically, they have a horizontal asymptote. It's where the graph gets really close to but never touches or crosses. And then you have your rational function, your basic parent rational function. That's where the graph lands in two different quadrants. In this case, the graph is landing in quadrant 1 and 3. And that's just y equals 1 over x. And we'll have an entire unit on rational functions. Okay, you good there?
Yeah.
Okay. Okay. So, what is a function? You obviously have heard this word before. It's a mapping from one set of numbers to the other. It's where the relation between a set of inputs and outputs, where each input has exactly one output. So the x values cannot repeat. Okay, so no repeating x values. And that's just more of an overview. Not necessarily, you don't really need to copy down everything verbatim here. Just you probably remember that a function can't repeat x's.
Okay.
Okay, you're good here. You want me to pause for a minute?
I'm good here.
Okay. Again, you don't really need to write a bunch of this down. This is just kind of reviewing older material. What is a function? What's not a function? So just let's look at these quick examples. You have in example 1 on where it says examples of functions, you have 0, 12, and 7 each going to just one time going to a y value. But then on the non-example, Do you see how you have two arrows going from the 2? So that indicates that the 2 repeats, so that's not a function. A function, remember, has to pass the vertical line test. Do you remember that?
Yeah.
Okay, perfect. I won't spend a bunch of time here. Tell me if you're okay if I go on.
Yeah, I'm okay.
Okay. Okay, again, you don't really have to write this as long as you know this here. F of x, do you remember that this is considered function notation? You're going to see this a lot. So f of x is read f of x, and it's called function notation. It essentially means the same thing as y equals.
Okay.
Okay. Okay, you're okay here?
Yeah.
Okay. Now we're going to do a little bit of evaluating. Okay. So I'll model a few and then I'm going to have you do a couple. Okay. Okay. So I'm going to model number 5. Number 5 says h of n equals negative 2 times n squared plus 4. And it says find h of 4. So I'm going to take that 4 and I'm going to stick it in the function where n is. So negative 2 parentheses 4 squared plus 4. Okay, I can either do the mental math, or in Honors Math 3, you're going to use Desmos a ton, actually, in just Math 3 in general. Have you used Desmos before?
Yeah.
Okay, so you can stick it into Desmos or you can do the mental math. I'm just going to go ahead and do the mental math, but if you want to do the calculations, or you could plug it into your, do you have a graphing calculator?
Yeah.
Yep, you could do that, or again, Desmos, whatever you want. But we're going to do exponents first. So 4 squared, 16, times negative 2 is negative 32. Negative 32 plus 4 is negative 28. Okay. Do you want to do number 7 for me? Tell me what you get.
Okay. I got 88.
88's correct. Perfect. So you stick that negative 8 inside of parentheses and then you evaluate. Excellent. Okay, let's do number 9. It says P of t equals 4t minus 5. Find P of t minus 2. So where we see t, we're going to plug in t minus 2. So we're going to say 4 parentheses t minus 2 minus 5. We're going to distribute 4t minus 8 minus 5, which ends us up with 4t minus 13. Okay, can you do this one for me in your notebook or wherever you're working? I'm going to say f of x equals 3x squared minus 5x. And I want you to do f of m minus 2. Can you do that for me and tell me what you get? Or do you want to do it together?
I'll try it.
Okay, try it. I'm going to pause my screen and do it as well, and then we'll share.
Okay.
Tell me what you get when you're ready. Or if you need help, just shout.
Okay.
How you doing? Okay?
Yeah, so do you have to do like m minus 2 squared, like in parentheses?
Yes. So you want to do that m minus 2 times m minus 2 first, which is essentially foiling. Then combine like terms, distribute the 3, then distribute the -5 and combine like terms. Do you want me to do it with you, or do you think you're okay?
Okay, so I got to the part where I distributed the 3,
Okay.
and I got 3m squared minus 12m plus 12 minus 5m minus 10
Minus 5m plus 10.
plus 10. Oh, okay.
Yep. Okay, perfect. Okay, now combine like terms. So what's -12m minus 5m?
Negative 17
M. And then 12 plus 10.
plus 22.
Okay, so final answer would be
3m squared minus 17m plus 22.
you got it. Perfect. Are you okay with that?
Yeah.
Perfect. Excellent. Okay, let's keep going. Ooh, this looks like a big one. Okay. So this gives us 3 functions. No. Oh yeah, I'm sorry. F of x, g of x, and h of x. It wants us to find 2 times f of 4 plus 3 times g of -3 times h of -1. Okay, so we are utilizing this function, and this function, and we are evaluating here. But what do we have to do first in this order?
You have to distribute it.
Okay, so do you see how this is the plus and then this is multiplication?
Yeah.
So we're definitely going to want to do this ending part first. Okay? So let's work almost kind of backwards here. Okay? So let's do h of -1. So we're going to take -1 and we're going to stick it into the h of x function. 3 times -1 minus 5. What do we get?
Negative 8.
-8. Okay, so we'll stick that over here. Let's find g of -3. And then what do we do with that outside 3? What do you think we have to do with it?
To distribute it and
Y-
multiply.
Yep, we multiply it by 3. Perfect. Okay, so let's find g of -3 first. So 4 minus -3, we get.
7.
And then that outside 3, we multiply that by 3 and we get
21.
21. Okay. And then we multiply 21 by -8 and we get
Negative 168.
-168. You got it. Okay. Now we have one last part to do, 2 times f of 4. So we find f of 4, get our answer, and do what with it?
You multiply it by 2.
Perfect. So plug 4 in. 4 squared plus 7, we get
23.
23. We multiply 23 by 2 and we get
46.
And then we do 46 plus a -168, and our final answer would be
Negative 122.
-122. Perfect. Okay, how did you feel with that?
I feel good about it.
You feel okay? All right.
Yeah.
Excellent. Okay, let us keep going. Okay, the next skill, which you may or may not have seen before, is evaluating functions from a graph. Okay, so we have here f of x. We have a graphical, can you see this okay? F of x.
Yeah.
Okay. Okay, so we have to find f of negative 4. So when our x is negative 4, where does it land on f of x?
Um,
So find negative 4 on your x-axis. Find the corresponding y on the f of x function.
is it positive 2?
You got it. Good job. Perfect. So positive 2, that's here, right? Negative 4, 2. Excellent. How about 0?
0?
Got it. How about 3? Oh, that's kind of a hard one. It doesn't really land necessarily at a good number, right? Um,
Yeah.
we'll
Like less than
y-
negative 2?
yeah, we'll say negative. Let's go negative 1.8. Does that sound good?
Yeah.
That's yeah, not very specific for us there. Oops, I meant to erase that. Okay, how about f of negative 5?
Is that 0?
Got it. Okay, and then E says, what is your x value when y equals 2? There's two answers here. When y is 2, what are your two different x values?
Is it negative 4
Negative 4.
and like negative
Point.
3 4?
Yeah, negative 0.75. Perfect. I'm fine with that. Okay, what is x when y is 0? Two answers again.
Negative 5 and 0?
Mm-hmm. You got it. Excellent. How do you feel with that? Okay?
Yeah.
All right. Okay, few more. This gives us two different functions this time, an f of x function and a g of x function. Okay? Letter A says g minus f of 10. So what we really need to do here is find g of 10 and subtract f of 10. Okay? What is our value for g of 10?
About negative 3?
Negative 3. What is our value for f of 10?
Negative 5?
What is negative 3 minus negative 5?
Um, 2?
Positive 2. Okay. Letter B says f times g of 6. So we have to find f of 6 and multiply it by g of 6. Okay. What is the value for f of 6?
Negative 5?
And what is the value for g of 6?
1?
Perfect. So our final answer is
Negative 5?
negative 5. All right. How did you feel with those? Okay.
Yeah.
All right. We'll keep going here. Okay. This one has a different notation here. This is a new notation for you. This is called F inverse. Okay. And so basically, when you see that notation, you look at Y and you find the corresponding X. Okay. So first, let's find F of 3. F of 3 here. Let's do this first one here. F of 3. Now, this is also probably something new. What do you notice when x equals 3? What do you have above and below the 3?
Um,
Do you see how this is open? And do you see how this is Closed?
Yeah.
Okay, when you have an open circle, it is a non-inclusive value. It does not include it. So if you were asked to find the value for f of 3, what would your answer be?
Um,
If the 2 is open, it can't include it, but what value is closed and can work?
-1.
See how it's at -2 here?
Yeah.
So f of 3 would be -2.
Okay.
Okay, so basically it was asked to you to, so you go to the x value, which is 3. It's open at a 2, but it's closed at -2, so you have to take the closed value.
Okay.
Okay, okay, now f inverse of -3. So this is, what is the x value when the y value is -3? So what is x when y is -3?
Just like -1.5.
Okay, so go to -3 on, so draw a line horizontally at -3. It hits the point with what x value?
-4.
-4. So we would say f inverse of -3 is -4.
Okay.
So whenever you see that inverse notation, you look for the y value, look at y, and then what is x at that y value.
Okay.
Okay? Are you okay there?
Yeah.
Okay. We'll cover, go over again. Not, it's not just like you'll never see it again. We'll definitely do review for sure.
Okay.
Okay. Can you try for me letter A here and tell me what you get? Okay. Try letter A. Tell me what you get.
Is it 17?
You got it. Excellent. Very good. Okay. Let's do B together. This is kind of a new notation for you. Do you see how there's like a bunch of parentheses there?
Yeah.
Okay, so we're going to read this f of h of 6. So essentially, you're working inside out. We find h of 6 first. What's h of 6?
3.
H of 6 is 3. So then we take 3, and for our final answer, we find f of 3, which is
4.
4. So f of h of 6 is 4. Final answer.
Okay.
Make sense there?
Yeah.
Okay. Woo, this next one, this last one, let's do that one together. It says -2 times h inverse of f of 4. Woo. Okay. So when you have multiple things crunched together like that, you're going to work inside out. Okay. So first, what is f of 4? 3. Okay, so f of 4 is 3. Next, we need to find h inverse of 3. So remember I said whenever you see that inverse notation, which is that -1, you look at y and find the x. So when y is 3 on the h of x function, what's the x?
Is it 6?
6. Perfect. So then your final answer is going to be -2 times 6, which we would say is -12. Good?
Yeah.
All right. You're doing amazing. How are you feeling? Okay?
Yeah. Wait,
Mhm.
so for the last one, where did the 3 go?
Okay, so we did f of 4 was 3. Step 2, we did h inverse of 3. And we said when y is, I'll use purple here. When y is 3, you said it's 6. So h inverse of 3 was 6. And then the third step was -2 times 6.
Okay.
Do you see how we kind of got rid of it as we went through the piece by piece?
Yeah.
Okay, excellent. All right, let us keep going. Okay, this is just a little application piece, kind of just, understanding functions in real life. It says the swine flu is attacking Porkopolis. The function below determines how many people have swine, where T is equal to time in days, and S is the number of people in thousands. What is S of 4? What value do you get when you find S of 4?
Is it 32?
32. And what does S of 4 mean in the context of the problem?
Is it the number of people in days?
Okay,
Like,
so remember S of 4. So 4 was the time in days, but our answer, our output was 32, which is the number of people in thousands. And so S of 4 means that after 4 days, what do you know?
there's 32,000 people.
With, yep, with the flu.
Yeah.
Perfect. Yep. So what does S of 4 mean? After 4 days, 32,000 people are infected. Okay, are you good there?
Yeah.
Okay, and then let's do C and D. So letter C says find T when S of T equals 23. So plug 23 in for S of T. Tell me what you get for your T value.
Is it 203?
Okay, so you're plugging, see how it says S of T equals 23? Look where that 23 is. We're placing it here. So we're saying 23 equals 9t minus 4. Solve for t.
Is it 3?
T equals 3. You got it. And so what does S of t equal 23 mean in the context of the problem?
Um, is it the number of days?
So after 3 days, what do you know? What is, go ahead.
Is it that 23,000 people got infected in 3 days?
Perfect. Absolutely perfect. Yep. After 3 days, 23,000 people have been infected. You got it. Good there? You okay with that?
Yeah.
Awesome.
Yeah.
Okay. Okay. Probably the last thing. Time just flew, right? We only have like 10 minutes left. Which is fine. You've been doing great. Um, So, the last thing that we're going to look at are your transformations. Now, I know you've probably done a bunch of with transformations from Math 2. When did you take Math 2?
I took it this semester.
Oh, wow. So, you haven't been in math since December?
Yeah.
Okay. All right. Do you remember the concept of transformations and like when a graph shifts left, right, up, down, reflects? Do you remember those or do you kind of need a refresher?
I think I kind of forgot. I remember doing it, but I forgot like the secret like formula.
Okay. Gotcha. Okay. So let's look at just kind of this one here. We'll start with this one. Okay, so it says graph the following functions and then state the, I mean, it has it done for us, but let's talk about the actual function here. Okay, so it says f of x equals x plus 2 squared minus 3. So you want to first always look at the parent function. So your parent function is going to be that quadratic f of x equals x squared. Now, whenever you have something added directly to the x, that is going to be a shift left. Anytime you have something subtracted, it's going to be a shift right. And that's inside of the parentheses or under the square root or inside the absolute value. Plus is left, minus is right. Outside is going to be a vertical shift up or down. So minus would bring it down, plus would bring it up. And that's always added or subtracted to the end. Okay. And that's what kind of this tells us here. It tells us the basic function is x squared. It shifts left 2 and down 3. So, just kind of as a side note, if I said y equals the square root of x plus 4 plus 9, where is this graph shifting horizontally? Where is it shifting vertically?
Um, is it moving left 4?
Left 4 and vertically?
Up 9?
Up 9. Excellent. How about y equals the absolute value of x minus 2? Where's that shifting?
Would it be left 2?
Okay, so remember, plus is left, minus is right.
Okay.
So it would be going
Right 2?
right too. And honestly, anytime, if you ever forget or you're having like a moment where you're like, I can't remember, you can always take and open up a Desmos tab. Let me do that so that you can see. Put your parent function in. Can you see my Desmos tab?
Yeah, it's loading.
Okay, it's loading. Perfect. You can see it okay? Well, still loading, sorry. Okay, now it's up.
Yeah.
Okay. So if you were unsure of yourself, sorry, I'm just going to move this little thing. I'm going to hit this keyboard here. I'm going to type in hello. Okay. Y equals the absolute value of x. Okay. And then there's my parent function. And then I'm going to say y equals the absolute value of x minus 2. Look where it goes. See how it goes to the right?
Yeah.
Okay, now watch this. What if I went outside of the bars and did minus 2? Where does it go? Down, because that's not attached with. Now, what about if I put a leading negative? What happens? Yes, it's an x-axis reflection. What about if I put a leading 2? What happens to the graph? Yes, it narrows it. It vertically stretches it. It's called a vertical stretch. What about if instead of 2, I put 1/2? What happens? Yes, perfect. So anytime you have a leading A, let me go back to our notes for a minute. Anytime you have a leading A in the front that is absolute value greater than 1, you are going to vertically stretch, so it becomes narrower. Anytime you have an absolute value leading A between 0 and 1, so greater than 0, less than 1, it's going to vertical compress or shrink. It's going to basically widen it. It's a vertical compression. Okay, so stretch or compression. And the reason why I put an absolute value symbol there is because it could say, watch this, let me go back to Desmos. It could say negative 3. See how it makes it skinnier?
Yeah.
So the negative doesn't matter. The negative just serves as an x-axis reflection. Okay? Okay, let's look at a couple. How are we doing on time? Oh my word. Time just flew. I thought maybe we'd get further, but that's okay. It is fine. You've done wonderfully. Okay, let's look at this one here. Now, it has a lot, gives us a lot of the answers, but it's okay. We'll look at it. Okay, so f of x equals negative 2 times the square root of x plus 3 plus 1. Okay, first of all, what does the leading negative do? Perfect, x-axis reflection. What does the leading 2 do? Yes, yep, it's a vertical stretch. Vertical stretch. What is the x plus 3 shift the graph? Good. And what about the plus 1 at the end? You got it. Perfect. Excellent. Okay. I think we're good there. That's just more of the shifts. That's more of the translations. Okay. All right. Let's look at a few examples. Number 1, can you tell me what happens to the parent function y equals x squared? What are all of your transformations there? Good. X-axis reflection. You got it, by a factor of 3. You got it. Beautiful job. Okay. Next one, number 2, the parent function is your absolute value. Y equals the absolute value of x. What are the 2 transformations that have happened on the function on number 2? You got it. Okay. And lastly, number 3 here, your parent function. Oh, I was trying to scroll down. I realized I can't scroll down anymore. Your parent function is your absolute value. Again, y equals the absolute value of x. What are the transformations that have occurred here? Perfect. Vertical compression. So the graph's going to get wider. You got it. Perfect. Okay. You did phenomenal. Now it is 4:43. So what we'll do is we'll stop here. I am going to stop our recording
Okay.
and I'm going to tell you what we'll do next.